something extraordinary is happening in rail technology, and it's unfolding not in the distant future, but right now. China is preparing to launch the CR450, a next generation bullet train capable of reaching speeds of 250 miles per hour or 400 kilometers per hour. This isn't just another high speed train, it's a glimpse into what the future of ground transportation could look like globally. The CR450 is the product of years of engineering, research, and testing. It's built to push past the long standing 350 kilometers per hour threshold, which has been a significant barrier due to one primary challenge: air resistance. At those velocities, nearly all resistance a train encounters is aerodynamic, but instead of backing away, engineers found solutions, studying the forms of fast flying birds to redesign the nose of the train for maximum airflow efficiency. That redesign alone cut drag by 2.6%. Even the bottom of the train, its undercarriage, was rethought. Often overlooked, this section holds the wheels and suspension systems. By developing a cladding that wraps around exposed components, engineers reduced drag under the train by an additional 22%. These small percentages add up, and they matter when you're moving at 250 miles per hour. But performance isn't just about speed, it's also about efficiency. One of the most remarkable aspects of the CR450 is that it uses the same amount of energy as China's existing 350 kilometers per hour trains. That's a massive leap forward in sustainable design, reaching new heights without increasing the environmental cost. Of course, moving faster means stopping safely becomes even more critical. The CR450 introduces a new brake system that can decelerate from 250 miles per hour to zero in just 4 miles. That process generates immense heat, enough to boil over 7 tons of water in 2 minutes. Developing materials that could endure this thermal stress took over a year of testing and refinement. All of this is happening on top of a vast existing network. China already has 48,000 kilometers of high-speed rail connecting nearly every major city. This network accounts for over 70% of the world's high-speed lines. The CR450 is designed to operate on that infrastructure, making it more than a prototype. It's a real, scalable transport solution. Now, while China accelerates its investment in the future, other nations are at a crossroads. The United States, for example, recently canceled $4 billion in federal funding for California's high-speed rail initiative. The project, meant to connect major cities like San Francisco and Los Angeles, has faced years of delays and political resistance. So here's the bigger question: not just how China did this, but why haven't others? The CR450 isn't simply about national pride or prestige, it's a demonstration of what's possible when there's long-term commitment to infrastructure, research, and innovation. The technology exists, the data is available, the need, environmentally and economically, has never been more urgent. This should be a wake-up call, not just to admire the progress elsewhere, but to ask ourselves, what's stopping us? Why can't we have energy-efficient high-speed trains connecting our own cities, cutting travel time, reducing emissions, and revitalizing transportation? If anything, the CR450 proves that it can be done, and that the longer others wait, the harder it becomes to catch up. If this discussion sparked a thought or even raised a few questions, we'd love to hear from you. Like this video to support independent tech analysis. Subscribe to stay updated on future innovations.